So, economic theory has developed a set of analytical tools in order to predict or to signal crisis episodes in the currency market. One of the most widely used tools is the so-called Exchange Market Pressure Index, which was developed by Girton and Roper in 1977 for the first time and was further extended by Waymark and H. Green, Rose and Whipples. This EMP index is a combination weighted average of the change in the exchange rate, the change in international reserve delta IT, and the change in interest rate. The exchange rate is defined as the price of foreign currency in terms of local currency, which means that an increase in the exchange rate means a devaluation. When the exchange market pressure index assumes value above a certain level, in this case there is a pressure to devalue the currency. And when this index assumes value under a certain threshold value, there is a pressure to revalue the exchange rate. These threshold values depends on the distribution, the statistical distribution of this index. The problem is that this index cannot be applied to the case of monetary union because we can't observe the exchange rate in the monetary union between countries belonging to monetary union. We can't observe the international reserves, the change in international reserves. We can observe just this variable, but it's not enough to derive an index of sustainability of monetary union. So we propose a new measure of exchange market pressure or an index in order to assess the sustainability of monetary union, and this is based on the issue or the topic of shadow exchange rate and the relation between this shadow exchange rate and the output gap required to stay in a monetary union. But in order to build a model, we use a simple second generation framework to currency crisis, and we combine some model in this setup, in particular Masson, Cavallari and Corsetti, and Berger and Wagner. We consider so a multi-country setting with two periphery countries, A and B, and in a monetary union, a larger monetary union, and the rest of the world. The periphery countries are denoted by A and B, and we assume in this paper that the structural parameters are the same in the two countries. In our paper, we will see countries with structural asymmetries. Now, the hypothesis in this model is that there exist nominal rigidities in the form of one period wedge contract. So we can write the aggregate supply for country A, but for country B is the same, as in this way, where delta STA is the actual change in exchange rate, and ET minus 1 delta STA is the expected change in the exchange rate. This means that this difference, under the assumption of that prices are fixed, the foreign prices are fixed, is the inflation through the channel of devaluation. Now we assume also that the worker output target is equal to 0, and we assume that all variables in the model are expressed in logs. We can write also the aggregate demand for country A. Remember that country B is a mirror image, so we have the same equation because are similar. And the aggregate demand can be written as the bar which summarizes the autonomous components of the aggregate demand, ρTA is the real effective exchange rate for country A, which is a weighted average of the exchange rate for country A, the exchange rate for country B, and the world exchange rate. The exchange rate are defined also in this case as the price of foreign currency, so the price of monetary union in terms of the local currency. An increase in the real exchange rate, real effective exchange rate, means that a real devaluation for country A. We cannot observe prices in this definition of real exchange rate because we assume that prices are fixed, and we assume that the adjustment is through the channel of exchange rate. So gamma is a sort of elasticity of the aggregate demand with respect to the real effective exchange rate. Then we have a shock affecting country A with some which is an IID random shock with the density function G of ut described by the following properties. So this distribution includes these properties includes the normal distribution. Now, the equilibrium in the goods market can be expressed by this equation in which the output is equal to the aggregate demand. This equation shows the effect of the devaluation of country B on the output for country A through the channel of competitiveness, because if we have a devaluation for country B, this means a reduction in output for country A. But we can see that the equilibrium can be written in this way, assuming that country A is in a monetary union, so that country A fixed the exchange rate, enter with a fixed parity as A bar. Country A in equilibrium can reach an output equal to YAF, which is equal to the autonomous components and the effect of a real effective exchange rate, in which the exchange rate with respect to the monetary union is fixed because the country is in the monetary union. This means that if there is a devaluation of country B, we have a reduction in output. But we can see that the output that country A can reach is equal to the output under the monetary union plus the effect of a potential devaluation if country A chooses to leave the monetary union, chooses to abandon the RPEG regime. So to set an exchange rate greater than the fixed parity, which means a devaluation. Now, consistent with second generation approach to currency crisis, country A have to minimize a loss function defined on the square output gap of the policymaker, because YTA is the output for country A, YA bar is the target level of the output for country A, and we have this differing exchange rate, which under the assumption of zero inflation rate for inflation rate, this is a proxy of the inflation rate for country A. So theta A is the relative weight of this term respect to this term in the loss function, so it's the inflation aversion coefficient. And CA is the opting out cost, which is a cost of carryability if country A chooses to leave the monetary union. So it's a sort of political cost for country A.